Welcome to Veteach. Now we will discuss another important topic in the unit 2, that is crashing for cost optimization. Before going to see this topic, now we will see what is the crashing. Now look here, this is nothing but by providing more or additional resources, reduce the completion of the project time. Okay, now look here, what is the meaning of the crashing? All of you just have a look on this board. Crashing, it is the method of reducing a project completion time by adjusting its scope or adding resources. Note this point, adding resources, adjusting project activities so that they are done in parallel and less time is consumed. Now in the crashing, what they are saying, our aim is reducing the project time by increasing or adding more resources. In that way, what the changes will come into the picture? Instead of going sequentially or one by one activity, sometimes depending upon the situation, you can go for the activities in concurrent or activities in parallel. Meanwhile, one activity, another activity parallelly going. At the same time, for example, at 10 a.m. morning, one activity is going. At the same time, another activity at the 10 a.m. also can be run. So you have to choose the situation like that. Okay, now look here. For example, activity 1, activity 2, activity 3, so on. They are going in the sequence manner. Instead of doing that, instead of doing this option, you can do in this way also. Run the activities in parallelly or concurrently or parallelly. This is the crashing. Now, so with this crashing, we will see the continuation of our topic, crashing for cost optimization. What is the heading? Crashing for cost optimization. Here our aim is optimum cost. The cost should not be too high, the cost should not be too low, in such a way that our cost will be present, will be there. Okay, now look here, there are some points are looking in the board. First point is establish the direct cost time relationship and analyze the past records data. Now establishing direct cost data means, already in the previous case we have seen the indirect cost graph, direct cost time graph. Indirect cost time graph is linear, direct cost time graph is curvilinear. So here, first based upon the previous record data, you try to plot a direct cost time relationship. Okay, now from that direct cost time relationship, determine or compute the cost slopes. What is the cost slope? That relation also we have seen. So where the curve is like this, the x-axis time, normal time, crash time, the y-axis cost, crash cost, normal cost. With that, get the cost slope. That is, for each activity, whatever the activities you are performing, for all those activities, try to get the cost slope and arrange them in ascending order. Note this point, arrange them in ascending order. Now, compute direct cost for the network with the normal duration of activities. What he is saying? Determine the direct cost of the network for each activities with the help of normal cost. Generally, as a estimator, to perform the activities, he assumes the time is normal time. That means everything is going in a normal situation. That is the normal time. So with that normal duration, activities compute the direct cost. Now, hash the activities in critical path as per the ranking. That is, starting with the critical activity having the lowest cost slope. Now here understand the meaning. What he is saying? Crash the activities. Which activities? Critical activities. What is the critical activity? Where the conditions are going in unexpected way. Situation is adverse situation, not favor to us. Everything is going wrong. So where the activities are consuming more time, means more time, more cost. So first you crash them. First you crash them. as per rank based. First, as per rank base, you have to crash the critical activities which are consuming more time, which are requiring more resources. So, rank based on rank, we have to crash the activities for the critical activities. That is the task here. That is starting with critical activities having the lowest cost slope. Now, continue the crashing critical activities in the ascending order of the slope. So, starting from 0 to last of the critical activities, continue in ascending, increasing order. So, how you are crashing? By increasing more resources and reduce the time. Once, for example, one activity is a critical activity. That means what? There, the time consuming is more, the material consuming is more, so money spending is more. So for that situation, you have to provide the extra resources. Then the time consuming is reduced. So that is the concept of crashing for critical activities. Just by providing additional resources, additional manpower, we are aiming to crashing. There you are reducing the time completion of the project. Okay. Now, so in the first case, rank based critical activities crashing. Next, we continue the crashing for the critical activities. Next, crash the parallel non-critical activities. So far, we have discussed crashing the critical activities. Now we are focusing crashing the non-parallel critical activities also. Or you can say parallelly non-critical activities. Critical activities crash and non-critical activities also crash. But after completion of the critical activities crashing only, you have to do the crashing the non-critical activities. Okay. So critical path duration due to crash the steps 4, 5. So whatever the steps 4, in the step 4, critical activities rank based crashing. Next, continuation of the critical activities. These are the previous steps. The same scenario is saying continue in the non-critical activities also. Now, continue till further crashing is not possible. You have to crash the activities until there is no crashing. If you are thinking there is no crashing, then stop. Until the no crashing possibility, you continue the crashing. That is, now after crashing for critical activities, non-critical activities, find the total cost of the project at every stage by adding indirect cost to the direct cost for each and every activities at each and every stage. Crashing performed, then we are able to find total project cost by just adding direct and indirect cost. Now you have to compute that. After that, plot the total project cost duration of the curve. Cost to duration. That means time on the x-axis, cost on the y-axis. Now you have to plot the cost duration curve. So take cost on y-axis, take time on x-axis, and with the previous crashing data and record of the previous data, try to graph or plot the curve. So with that cost, you will get the some normal time, crash time, normal cost, crash cost on the x-axis and y-axis. With that, you can get the our required optimum cost. Here our task is calculation of optimum cost that comes from the graph plot. Okay. Now pick up the optimum duration corresponding to least project cost. That is our task. So crashing for cost optimization. So you have to pick the cost which is on the y-axis with the least time. That means optimum time. For example, if you got the graph like this, so here I have the normal time. Say this is the crash time CC, normal time TN. With respect to this, the time is cost is crash slope. With respect to this is normal cost. So somewhere here you will get optimum cost that is optimum. So this might be optimum time. With respect to this optimum time, the cost you got is optimum cost. Optimum cost. Optimum cost. So that is the way of getting the data or crashing the cost optimization. Okay, this is about the crashing for cost optimization. Next we will see the another topic, that is updating. What is updating? When we do updating, that we will see. Thank you.